Alrighty, well, let's begin. If you had a textbook, this would be on page 226. If you don't have a textbook, so you really don't care. That's more of a reference for me. We're going to be balancing equations. The whole idea of a balance is, like that one I have up there, right, is if you add, actually, what Logan, can you do me a favor and get that balance out? I'll just do a little visual here, right? Okay, so you guys can follow along in your little sheet there and fill in some blanks and stuff. So the first thing that I'm going to show you is what's called a skeleton equation. Jesse, did I give you one? Okay, good. Now, a skeleton equation, like a skeleton is simply a human body with no organs or skin, right? Just the bare bones, if you will. Right? Just the bare bones. So a skeleton equation converts the word equation into one with formulas. So when you take the word equation that says, like, methane plus oxygen gives you, when you take that kind of thing and you convert it into something with formulas, that's known as a skeleton equation. And skeleton equations are unbalanced, not balanced. The left side, the reactants, does not equal the right side, the products. I.e., the number of atoms are not the same on each side. And so the next step in this process is to make it balanced. Okay, so there is an example of a word equation, right? Am I going too fast? Here's an example of a word equation. Methane plus oxygen gives you carbon dioxide and water. Doesn't say how much water, doesn't say how much carbon dioxide, doesn't say anything about how much, right? And if we convert that into formulas, methane, you might remember, is CH4, natural gas. That's what's heating your homes. That's what cows fart. We're literally heating our homes with cow farts. Methane plus oxygen gives you carbon dioxide plus water. So that's water vapor that's coming out of your furnace there. That's why it sometimes freezes up, because there's a little bit of water there. Carbon dioxide. Okay, is this balanced? Let's do an atom analysis. We're going to find out, we're going to do our atom counting, which is what we did yesterday, right? Our atom counting? Okay, so how many, now the way I like to do it is I like to write all the atoms sort of down the middle, and then I just do left side, right side. Instead of having to rewrite them, okay, just whatever's on the left side of the equation is going to be on the left side of the atoms, and whatever's on the right side is on the right side, right? Okay, so on the left here I got how many C's? I got one. I got one C. Pirate's favorite letter. One C. How many H's on the left-hand side? How many O's? Okay, everybody good with that? Jesse, this is what we did yesterday, okay? On the right-hand side, how many C's here? How many C's? Just one. How many O's? I got two O's here, one O here, so I got three O's. Uh-oh. How many H's? Two. Is it balanced? Clearly, it is not. Okay? It is not balanced, and the law of conservation of mass says that the number of atoms on both sides of the arrow must be the same, right? And the mass of the atoms the number of atoms on each side of the arrow must be the same, and the mass of the atoms. Okay, so what can we do to make it balanced? What can we do to follow the law of conservation of mass? Because it is the law. Can I change water? Can I change this to H4O? That's not water anymore, is it? Right? So I can't change the formula for water, but I can change the number of waters that are produced. I can change the number that is in front. Well, what's the number in front right now? It's 1. But I can change that, right? I can change the number of waters that is produced to make it balance. So that's kind of the idea. Okay? There is the balanced equation. Okay? So what I did was I put 2 in front here. Should we do this atom analysis again? C, H, and O. How many C's? 1. How about we do it this way? How many C's? How many C's over here? 1 CO2, 1 and 1. How many H's on the left? 4. How many H's over here? Oh, I got 2 H2s, which is 4. How many O's on the left? 2 O2, that gives me 4. And over here I have 2, and then I got 2 more O's here, right? Maybe I'll write it like this. 2 plus 2 is 4. Is it balanced? It is. I have to throw it up. I'm fighting this cold, and I can feel it. Okay. So the question is now, how do we come up with these numbers? Do we just sort of guess? Well, there are certain sort of steps that you can take that are sort of making it easier. So let's look at those. Here they are. Steps to balance. So the steps are, write the word equation if needed. You won't always need it, okay? But sometimes you might. So for example, iron plus oxygen gives you magnesium iron oxide. Why do I have magnetic? Not magnesium. I shouldn't even have the word magnetic in there. Iron oxide. Okay, write the word equation if needed. 99% of the time, you're not going to need that. Write the skeleton equation if needed. Most of the time, this is where they start you. They give you the skeleton equation, and they say balance it. So, iron plus oxygen, iron would be Fe. Oxygen is one of those diatomic gases, O2, that I may not have sort of covered as much as I should have in the past, so that's one reason why you're going to get the skeleton equation. Gives you Fe3O4. Now, I've shown you how to come up with these formulas. That is still a challenge for several of you. If you're going on in chemistry, you're going to have to be able to be competent to be able to do those. Okay? I'm not going to spend a lot of time on that now. Okay. Identify the reactants and products. Remember, Ruben, the reactants are always where? On the left, right? Products are always on the right. Okay. Count the number of atoms on the left and right. You see how this is sort of like everything we've been doing up to now is kind of leading up to this? This is kind of the big daddy of grade 10 chemistry. This is the, can they do balancing equations? And then when all the students do, then all the teachers have a big party because we're happy. No, we don't. Okay, so let's count here. How many FEs on the left? Just 1. Uh-oh. How many FEs right here, Logan? On the right? 3. Uh-oh. How many O's here on the left? O2 is 2. Here I got O4, 4. Clearly, this is not balanced. Okay? Now, this is something new that I've discovered that I'm going to do because I think it's going to help. It says, draw boxes around the formulas. Don't go inside the boxes. It said to yell. Capital letters, right? Don't go inside the boxes. So what they're saying is, and so for some of you this will be helpful, for others it won't make a whole deal, but what they're saying is you're going to do this. And the reason that we do this is because some kids in the past want to change the 3 and the 4. Can you change the formula? No. No. Okay, so doing the boxes just sort of reinforces that. You can't change the formula. You can only change the numbers where? On the outside. The outside of the box. In front of the boxes. Sorry, I guess it'd be this way for you guys, right? You can only change what's outside the boxes. Don't go inside the boxes. Okay? Now, what do you guys have there? You guys have it like this, right? And I think I purposely left some space. Okay, so put the boxes. Do not go inside the boxes. I can't be more emphatic with that. Okay, now, balance by adding numbers in front of the formulas. Now, if you're working in pen, get a pencil. Because you're going to make mistakes. There's going to be times when you have to, you give some here, and then you give some over there. Oh, then I got to go back, right? Kind of like me in the balance there, right? Okay. I'm just laughing at these two here. How she just automatically had it in the pencil. Balance by adding numbers in front of the formulas. Okay. And then when you're done that, check by counting the atoms again. Okay, so let's balance this. Careful, don't lean forward. Balance by adding the numbers in front of the formulas. So, I don't have enough O's and I don't have enough FE's on the left-hand side, do I? I need to get how many E's? How many FE's? Well, I got to get it to 3, don't I? Right? So, can I put a 3 there? I put a 3 there, and that takes that to 3, and so far we're good, right? And on the left here, I need more O's, so what would I do? Times it by 2. And now I got 2O2, that gives me 4. Now you don't really need to do this, check the counting, as long as you sort of do this. And this is how I do it, I cross it out, sort of. Does that work for you? Okay.
What if you could do it just like mentally? I know just write the answers. Can we do that?
You can, except that as they get harder, you're going to need to be able to do this kind of thing, right? So, I mean, it's a good idea to get in the habit of doing it. Okay, does that make sense what we're doing? We're balancing here. Jesse? Tiffany, yeah? Okay, let's try some in practice, okay? Okay, here's some sort of tips. Whenever you change a number, make sure to update the inventory. It's like a puzzle. When the number and the type of atoms on the left equals the number and the type on the right, your inventory is equal on both sides. The equation is balanced. Make the odd atoms even. It will help. Making the odd atoms even will help. For example, 1 H2O has only 1 oxygen atom, but 2 H2O has 2 O's and 4 H's. So when you get something like this, making them even definitely helps. This is sort of a rarity here because the 3 is on the right, but quite often that will help. It will make it easier to balance the other atoms because they're all even. Okay, so let's try this one here. This is an example I think you guys have, right? Bottom of page 2. Write the word equation, magnesium metal plus nitric acid gives you hydrogen and magnesium nitrate. I'm just giving you that. Oh, wait a second. Okay, now we're going to write that as a skeleton equation. So magnesium metal is just plain old Mg. Nitric acid, you probably don't know, is HNO3. Hydrogen gas is one of the diatomic gases on the right-hand side. It's H2. And magnesium nitrate, you'll remember from the polyatomic sheet, MgNO3 too. Now, I'm not going to spend a lot more time on how we come up with that. I guess you'll have to be thinking about registrations pretty soon. That's going to be coming out. Okay, do the counting. How about I let you try the counting on your own here? Good practice, right? So what are they? M, G, H, N, and O. You guys go ahead and do the counting there. I'll wait a couple minutes, and then we'll do it together. Well, I'll do. Oh, I'm still recording. Didn't mean to do that. How many mg's on the left? That's an easy one. Just one. How many mg's on the right? MgNO32. The 2 only refers to what's in the bracket, so how many mg's? Just one. So far we're good. How many H's on the left? 1. How many H's on the right? 2. How many N's on the left? I got an NO3. I got just 1. Here I've got 2 NO3s, so that's 2 N's, right? NO32, that's 2 NO3s. How many O's here? 3. How many O's here? 6. Okay, Ruben, so far so good? Okay, next up, draw the boxes. And again, some of you won't find this step necessary, but when in doubt, right? And remember, you can't change anything inside the boxes, right? Balance by adding numbers in front of the formulas. Okay, so what do I need? I need, the MGs are good. I need more H's, I need more N's, and I need more O's, right? How many more H's do I need? I need one more. I need 2 total, right? So I'm going to put a 2 there. And what does that do? Changes that? Does it change the number of N's, Tiffany? How many N's? Stay with me here. How many N's? I got 2 HNO3s. That's 2 N's, right? And now I got 2 O3s. That's a total of? Total of what? Come on, you guys. 2 HNO3s. 6. And what do you know? Everything is? Is that not an easy one or what? Right? So what goes in those spaces? Well, technically it's 1s. Do you need to write them? No. Okay. Do I need to check by counting atoms again? Or I did it as I went, right? Okay. Here's one to try. You guys try that one. We'll do it together right away. A little harder. How we do? Need more time? Hello. Buenos dias, senores. Senores and juniors.
Good morning.
Good morning.
Good morning.
So you write down what you got. You got FEs, you got CLs, you got BEs, you got Ps, and you got Os, right? You got lots of atoms here. How many FEs on the left? Just one. How many on the right? Oh, that's good. How many CLs on the left? 3. Only? Not good. How many BEs? How many BEs? How many Ps here? Right, PO4, 2. So you got 2 Ps. Here we only got 1. How many O's? PO4, 2 is going to be 8. And how many O's here? 4. Okay. So again, making things even helps. This CL3 is going to be a pain, right? Okay, so let's put a 2 there to make that become a 6. And what does that also do to my FEs? That makes that 2. Okay, so we made that 6, which means we got to make this CL6, right? Can I make that 6? How do I make this CL6? Remember, I can only put it inside that there, so that's going to be 3. And that's going to make that 6. Oh, and look what this does. 3 BEs, right? Which does what? That fixes that one and didn't even mean to. Now what else? Clearly, I have to make the right-hand side bigger here, right? I need more P's and I need more O's. So what if I just put I need 2 P's, so let's put a 2 there. That makes that 2. It makes my O's how many? 8, right? 204. And it also makes 2 FEs. Look at that. The teacher version of mic drop. I'm afraid to lean over to pick it up though.
Isn't the second example equation already balanced?
This one?
Yeah.
Is it really?
I counted all the atoms.
Okay, well let's check it. Maybe I threw that in there as a sort of a tester. Logan. Oh, now what about these O's here? Is that the same O? It's the same O, right? Okay, well let's do the count. So how many you got on the left here, Chloe? 1 AG, 1 AG, N, just 1, 3 O's, plus 1 more O here gives me 4. If you want to write it as 3 plus 1, you can. 1 plus 2, oh, look at this. Li, 1, 1. How many H's? 1. Pre-balanced. That might happen to you. Okay? Tiffany, okay? Yeah? Let's try this one. Should I do it right now? You guys are very agreeable. MG, MN, and O. How many MGs? 1. How many MGs? 1. How many MNs? 2. Only 1. How many O's? 3. 1. Okay, where do you start? Start with the mg's. They're both 1 though. We're going to make more mn's, right? Okay, if I put a 2 here, then that's going to balance that one, but my O's are still going to be out of whack, right? And the only way to make these O's balance, there's no way I can make, oh no, I could make that 3, couldn't I? Okay. So this might be a case where changing it to even might not be helpful. But you know what, let's just see what happens here. Let's go with the advice to make this 3 a 6, like to make it even. So if I do that, if I put a 2 there, then that makes that 4. That makes that 6, right? Which means I got to do what over here now? I got to make that also 6 to make that go. And then that makes 6 mg's. And I got to make my mn's more, so I got to put a 4 there. And I still got to balance this mg, and so that means I got to put a 6 there. So I got 6, 2, 6, 4. Is that balanced? It is, but it's not what? It's reduced. Not reduced, kind of like fractions. So really, I could have gone just 3, 1, 3, and 2, right? Which is what you would have got if you had done it sort of the way you guys want to, right? So making that 03, making that 6, making it even will help, but it sometimes creates unreduced one. Okay? As long as you recognize you have to reduce it. Okay? Sometimes you get yourself into a mess and you can't get out of it. Sometimes it's best just to erase and start over again and take a different sort of route. White cow in a snowstorm.